I think the main takeaway from this study is that we have found a new mechanism to explain how fluid pressure increases and triggers earthquakes deep underground and through the process of oil field wastewater disposal. And that mechanism is simply that if we put high density water, right, so heavy water into a system, it sinks. As it sinks, it moves fluid, it increases fluid pressure by displacing lower density fluids. That fluid pressure can destabilize faults and trigger earthquakes. We found that this process is robust. It can persist in the environment for long after we stop injecting the fluids. And we also found that as you get deeper underground, the relative proportion of high magnitude earthquakes goes up. So even though there are fewer earthquakes down there at these greater depths, 8 to 10 kilometers, the percentage of them will be higher in magnitude, right? And so that has some very interesting and I think important consequences for how we understand the hazard posed by oil field wastewater disposal when we have a high density contrast. When we think about what this study doesn't say, I think it's important to recognize that this study is not predicting a large magnitude earthquake. Right? We're not saying that there will be a large magnitude earthquake. What we are saying is that on average, the proportion of higher magnitude earthquakes increases with depth. But we're also very careful to point out that there are far fewer earthquakes at depths where the higher magnitude earthquakes are occurring. So I think the take-home message in terms of being cautious about interpreting these scientific results is that we've presented a new process to understand how fluid pressure increases and triggers earthquakes. We see evidence that this fluid pressure moves deeper over time, and we see evidence that there are the relative proportion, the percentage of high magnitude earthquakes increases with depth. Okay? And that's where we stop, right? We can't make any predictions about what the magnitude distributions are going to be. The density of the fluid is not a causal mechanism for the earthquakes. It simply changes the fluid pressure. And so we're pretty careful to avoid overstating what we found with this study.